Welcome to today's video on thermodynamics. Thermodynamics is a branch of physics that deals with heat, work, and the forms of energy transfer between systems. Let's start with the basics, the laws of thermodynamics. The zeroth law establishes the concept of temperature. If two systems are each in thermal equilibrium with a third system, they are in thermal equilibrium with each other. The first law of thermodynamics, also known as the law of energy conservation, states that energy cannot be created or destroyed, only transformed. It's often summarized as the change in internal energy of a system equals the heat added to the system minus the work done by the system. The second law of thermodynamics dives into the concept of entropy. It posits that in any energy transfer or transformation, the total entropy of a closed system will either increase or remain the same. It never decreases. This explains why certain processes are irreversible and tells us why heat flows from hot objects to cold ones, but not the other way around. The third law of thermodynamics states that as a system approaches absolute zero, the entropy of that system approaches a constant minimum. In simpler terms, it's impossible to reach absolute zero in a finite number of steps. This principle helps us understand the behavior of materials at extremely low temperatures. Key concepts in thermodynamics include internal energy, enthalpy, and Gibbs free energy, among others. Internal energy is the total energy contained within a system. Enthalpy is the measure of a system's heat content. Gibbs free energy determines the spontaneity of a process at constant temperature and pressure. Thermodynamics also explores different kinds of thermodynamic processes. Isothermal, where the temperature remains constant. Adiabatic, where no heat is exchanged with the environment. Isobaric, which involves constant pressure. And isochoric, where volume remains unchanged. The applications are vast, influencing fields from engineering and chemistry to environmental science and even economics. Heat engines, refrigerators, and even biological processes like muscle contraction and metabolic cycles all rely on principles of thermodynamics. And there you have it, a concise yet comprehensive look into the world of thermodynamics. While the subject is rich and complex, understanding these foundational principles will enable you to have an informed conversation with experts in the field. Like and subscribe for more videos like this.